The first terms of a sequence are 7, 13, 19, 25 and 31. Prove that the difference between the squares of any two terms of the sequence is always a multiple of 24. The nth term is 6n plus 1. Another term is 6m plus 1. We square both terms and subtract, and then collect like terms. We can now take out a factor of 12 and group the m's and n's. The square bracket needs to be even so that the whole expression is a multiple of 24. The round brackets need to both be even or both be odd, as an odd number take away an odd number is an even number, and an even number take away an even number is an even number. So let's take the 3m squared plus m and see what happens if m is odd. If m is odd, we can let m equal 2k plus 1. When we substitute that into 3m squared plus m, then we expand and simplify, and then we take out a factor of 2, we find that it is even. But what if m is even? If m is even, we can let m equal 2k. Once we substitute that into 3m squared plus m, and then we expand and simplify and take out a factor, we find that it's still even. So actually in the round brackets, it's definitely even numbers. We've proved that the square bracket is even, so it's a multiple of 24, as long as it's greater than or equal to 2. The square bracket cannot equal 0. M is never equal to n, as they're different terms in the sequence. The smallest can be m equals 2 and n equals 1. This gives us 12 plus 2 in the first round bracket, minus 3 plus 1 in the second round bracket. Therefore, the smallest number in the whole square bracket is 10. The question said, the first terms of a sequence are 7, 13, 19, 25 and 31. Prove that the difference between the squares of any two terms of the sequence is always a multiple of 24, which we have done.